Okay, so the final section in this chapter is synthesis strategies, just like pretty much every other chapter that we're going to encounter in the second semester. And we've learned how to, via reduction or oxidation strategies, interconvert ketones and secondary alcohols. So that's a good synthesis strategy now. We've learned how to take primary alcohols and convert them back and forth to aldehydes. And we know how to oxidize aldehydes to carboxylic acids. We've also learned how to use Grignards to add carbon groups to aldehydes and ketones. So we know that aldehydes can become secondary alcohols, and ketones can be converted to tertiary alcohols. So the Grignard is a very, very important carbon-carbon bond forming reaction. So you should keep this in mind just about every chapter for the rest of this semester. It's a very important reaction. You can find a great summary figure in the final section of this chapter, and basically it goes through alkenes, alkynes, and alcohol interconversions, and we're going to build on this figure throughout this semester. So we know, just for instance, I'm going to just do some free drawing here. We know how to turn an alkene into an alcohol, and then of course we learned how to take that alcohol into an aldehyde and further oxidize it to a carboxylic acid. We can also take that alcohol and turn it into an alkyl halide, and that alkyl halide can be converted into a Grignard. And we can react the Grignard with a ketone or aldehyde and come up with, let's see here. Come up with a secondary a secondary alcohol that can be oxidized to a ketone. That ketone can be further reacted with a Grignard. This secondary alcohol can be converted into an alkyl chloride or alkyl halide. We can turn that into a Grignard. We can repeat this process ad nauseum. And so if you can just sort of go through all the different reactions that we've learned this chapter and combine them a little bit with alkene, alkyne, and alkyl halide type reactions from semester 1, you've got a whole mess of synthetic pathways that you could deal with. So we've outlined one today. What if we used, this is our product, this is our starting material, and now you've just created a synthetic problem that you can share with your friends. Of course, you know the answer, but you can share it with your friends and let them work on it, and they can create their own and let you work on it. So let's look at a few examples of this. The question might say, propose a viable synthetic pathway that produces the indicated product in high yield. And so we're going to focus on reactions that are regioselective, give us some control, limit the number of byproducts. So let's look at this one. We have 4 carbons, and somewhere in our product we can find those same 4 carbons maybe, indicating that this bond needs to be created. And we know how to create carbon-carbon bonds next to carbonyls. We know how to make carbonyls from alcohols. So perhaps we might look at this as, well, the final step might be some sort of oxidation of this alcohol. That might be reasonable, and again, that would allow us to create this bond. So I could make that bond via the appropriate Grignard and the appropriate aldehyde. So now you see I'm getting closer to my 4-carbon alkene. Really, I just have to somehow put a carbonyl on carbon 4. I know how to do that through hydroboration oxidation. Sometimes I'm a little lax in my reagents here, but I'll try to be accurate. So NaOH, H2O2, that gives us the alcohol on the outer carbon of our alkene. Then we can oxidize that, let's use PCC perhaps, to the aldehyde. We can add the Grignard, that's our first step. Second step is, of course, work up with water, and then oxidizing, again, we could use PCC, or we could use the Sworn oxidation, or we could use Jones in this case, because there's nothing else that could happen besides turning our secondary alcohol into a ketone. So here we have a nice 4-step synthetic process. It involves a couple of oxidations, and it involves a Grignard step. We knew that it had a Grignard step because we observed that there were 3 additional carbons added to our product compared to what we started with. All right, let's look at the molecule down here. I'm going to switch colors a little bit. We have the 5-carbon ring, of course, and we see that again right here. Then we have 2 carbons hanging off that ring. It's probably safe to assume that these are the 2 carbons that I marked in my starting material. And so now I have to figure out a way to make a tertiary alcohol, and I have to figure out a way to make this carbon-carbon bond. And so those 2 clues together are a very good indication that we probably want to have a Grignard and some sort of carbonyl compound. In order to get a tertiary alcohol, I need to start with a ketone, and I need to mix that with a 3-carbon Grignard. My first step, and of course the second step, is reaction with water. Now the question is, how do I get my carbonyl compound from my alkene? Well, I know that anytime I have a ketone, I can take the equivalent secondary alcohol and oxidize it. We could use PCC here if we wanted to. And to get to the secondary alcohol, I could just add acid in water. H3O plus might do this for me, but I hope you can find a problem with this proposed addition of water to this alkene. What's wrong with adding H3O plus to this particular alkene? Well, if you think about the mechanism, we would involve, I'm going to draw it up here so I don't screw up my synthetic pathway, but the first step would be protonation of the alkene to make this cation. We should observe there's a tertiary site right next to it, and a hydride shift would give us the tertiary the tertiary cation, and that is not going to help us achieve our goal of the secondary alcohol that I have drawn in my pathway. So we should not use H3O+. We should use a different method to install that alcohol on the more substituted portion of the alkene, but avoiding the formation of the cation. And to do that, I hope you remember from the Addition to Alkene chapter, mercuration. So mercury diacetate and water, followed by NaBH4 to reduce the carbon-mercury bond. That will give us the secondary alcohol without rearrangement. We can oxidize that to the ketone here, and then we can add our propyl Grignard to the ketone, followed up with water quench to get to our tertiary alcohol. So you can see, again, I have a 3-step sequence. It involves some oxidation, some Grignard addition, and it involves some chemistry from Organic 1. We're going to need to know how to do substitutions, eliminations, and additions to alkenes throughout the second semester of organic chemistry.